vision. So today's topic is antenna synthesis. The last experiment, what we did antenna analysis. Okay, we were given an antenna array and we had to find out the radiation pattern. Okay, in this experiment, we will do the opposite thing. So that is, we will be given the radiation pattern and we need to find the antenna array which will match the given radiation pattern. Is it okay? So we will be given a particular pattern which we desire and we have to find out an antenna array which will give us that pattern. Right? So this is antenna synthesis. Okay. There are many methods of doing that, but we will do probably the easiest method, that is the Fourier series method. Okay. So Fourier series method you have studied, I think, in your network class. So it goes like this. First of all, Fourier series can be used for which type of functions? Fourier series method can be used for which type of functions? Which type of functions can be expanded as a Fourier series? Please hold for a second. Okay, sorry. Yes, periodic functions, absolutely right. So, periodic functions we can express in the form of Fourier series, right? Now, antenna patterns, whatever we are doing, okay, we are plotting the pattern from 0 to 2 pi or minus pi to pi, whatever, okay. Now, if we go on from 2 pi to 4 pi or the 4 pi to 6 pi, obviously the pattern will repeat, right? The pattern at pi by 2 and 5 pi by 2 will be the same, and again 9 pi by 2, right? So they are periodic. Yes, integrable also. They are Dirichlet conditions, right? Okay. So how to expand in terms of Fourier series, right? Now for any array, as we have seen already, Ez or the absolute value of the electric field, it was written in the form like this: A0, A1 Z, A2 Z square, AM minus 1, Zm minus 1, AM Zm, AM plus 1, Zm plus 1, and like this, we assume that the antenna array has 2m plus 1 elements. number 1, and number 2 is z equal to e to the power of j psi. See, all the antenna arrays we have discussed so far, they are all in this form. Is it okay? Is it okay? All the antennas which we have discussed so far, antenna arrays, they are in this form, right? Now, obviously, since E is z equal to e to the power j psi, obviously mod of z equal to 1, right? So, we can multiply here with mod of z minus m. That will not make any difference. I didn't write some terms. We can write this. We can write this. So, this becomes mhm. We can write this. Can we write this? Now, we do one thing. We take some terms together. What I mean is, we express our sum in this way. A0 z of minus m plus a to the power of 2m z of plus m, sorry. Can we write it in this way? Sorry. Can we write it in this way? We take the z to the power minus m and z to the power m terms together. Okay? Two terms at a time. Is it okay to write it in this way? Is it okay to write it in this way? Now we assume that for our convenience, a0, or rather a to the power of 2m is the complex conjugate of a0. A to the power of 2m minus 1 is the complex conjugate of a1. In general, a to the power of 2m minus k is the complex conjugate of ak, where k lies from 0 to m minus 1. Okay, which means if a to the power of 2m is say a0, or rather ak j bk 2m minus, sorry, if ak is equal to ak plus jbk, then a of 2m minus k, that will be ak minus jbk. We assume this, okay, for our convenience, that the two extreme arrays elements are complex conjugate, then the next two extreme elements are also conjugate, complex conjugate, and so on. Is it okay? Is it okay? Which means this and this complex conjugates, these and these, they are complex conjugates, these and these, they are complex conjugate, and so on. Okay, this is the way. This is the way. So if we expand this, what do we get? E of phi is equal to a0 plus jb0 e to the power of j0 phi a1 plus jb1 e to the power of j psi a2 jb2 e to the power of, and so on, a m minus 1 jb m minus 1 e to the power of m minus 1 psi plus am. This am stays alone, a m plus 1, rather a m minus 1 minus j b m minus 1 e to the power of j, sorry, here it will be negative, this will be negative, minus z, right? Sorry. So what we can write is e to the power of psi, that will be a to the power of minus m plus j b to the power of minus m z of minus m plus a minus m plus 1 Okay, so this becomes hmm. Okay, so we take that the extreme elements are complex conjugates of each other. So this one is 0 z of minus m plus a m, sorry, a to the 2m z of m. We can write this as in this how. This can be written as ak plus ak minus jbk z to the power of minus m plus ak plus jbk z to the power of m, or rather this will be am, sorry, am j sorry, this will be am minus jb am z to the power of minus m am plus jbm z to the power of m. That will be am z to the power of minus m plus z to the power of m plus jbm z to the power of m minus z to the power of minus m. We can write it in this way. Okay, so this will be 2am cos of m psi plus bm sin of m psi, where sin of m psi equal to e to the power of j m psi by 2j cos of m psi e to the power of j m psi by 2. Yes, yes, this way. See it in this way. We take two elements, okay? Two which are complex conjugate to each other. Right? Since they are complex conjugate, we can express them in this way: am minus jbm and am plus jbm. Okay? Since they are complex conjugate, we can express this in this way. And then we take common. Okay? And what is zm? Z equal to e to the power of j psi. So z to the power m will be e to the power of j m psi. Okay? So in general, ak z to the power of minus m, or z to the, sorry, ak z to the power of minus k plus a of m minus k z to the power of k, this will be this will be wait. So in general, am minus jbm okay. So we have to this, let us do it again for you because it is getting confusing for you. We had up to this, okay. So now we take this one. These two are complex conjugates of each other. So how can we write them? A z to the power of minus m plus a to the power of 2m z to the power of m, okay. This can be written as a to the power of m minus k z to the power of minus k plus a to the power of m plus k z to the power of k. We can write this, okay, where in this case k equal to m. We can write this in this form. Is it okay? Now what we need to do? Since they are complex conjugates, we can write a of m minus k, that is a of k minus j of b k, a of m plus k a k plus j b k. We can write this because we have assumed that they are complex conjugates, okay. So this will be equal to a k minus j b k z of minus k plus a k plus j b k z of k. That will be a k z of minus k plus z of k plus j b k z of k minus z of minus k. We can write this. Now what is z? Z equal to e to the power of j phi. So that is a k e to the power of minus j k psi e to the power of j k psi plus j b k e to the power of j k psi e to the power of minus j k psi. So that is 2 a k cos k psi plus 2 b k sin k psi. Can we write this? So this expression a to the power of m minus k z to the power of minus k plus a to the power of m plus k z to the power of k can be written in this form or not. Is it okay? Just see this derivation, nothing else. Just see the black derivation. You can ignore whatever was before. Is it okay? Is it okay? Can we write it in this form? Right? Similarly, so what other terms we had? We had a0 z of minus m, a1 z of minus m minus 1 plus a2 z of minus m minus 2 a m minus 1 z am plus 1 minus z a to the power of 2m zm. So we take two terms at a time, and we can expand them for different values of k. So the value of k, it goes on from k equal to 1 to m, and this term stays alone. So e of phi, that is equal to am plus summation k equal to 1 to m ak cos k psi plus k equal to 1 to m bk sin k psi. Can we write this? Okay, can we write this? Is it okay to write? Finally, if we assume, last assumption, am equal to a0, then e psi equal to twice a0 by 2 k equal to 1 to m ak cos k psi, sorry, 2 will be out, 2 is out of the bracket, plus k equal to 1 to m bk sin k. Is it okay? This is the Fourier transform expansion of any Fourier series expansion of any antenna pattern. Is it okay? And how to find the values of these terms? Check it here. Okay, and how to find out these values? A0 is given by 1 by 2 pi minus pi to pi mod of E psi B psi ak 1 by 2 pi minus pi to pi E psi cos k psi B psi bk sin k psi B psi. Are they okay? Right. Now let us solve an example. Suppose we need to synthesize this array. Okay, if phi equal to 1 for 0, pi by 3. If phi equal to 0 for pi by 3, pi to 2 pi by 3, and if phi equal to 1 for 2 pi by 3, pi to pi. Okay, so 0, pi by 3, 2 pi by 3, pi, and by symmetry, of course, the pattern repeats. So this is the pattern we need to synthesize. So this is a broadside pattern or an end-fire pattern. This is a broadside pattern or an end-fire pattern. Which one is the case here? This is a broadside pattern or an end-fire pattern. Axis we have not. Which one? For where? Oh, axis. For example, if we have added like this will be the axis on which the array is there. Okay, so it's an end-fire pattern, right? Now we need to first of all find psi. What is psi? Psi is kd cos phi plus alpha. So since it is an end-fire array, okay, we need to choose alpha equal to either pi or minus pi. We choose alpha equal to minus pi. And d equal to lambda by 2. Okay. So psi equal to pi cos phi minus pi or pi cos phi minus 1. Is it okay? Is it okay? So now how to map? We are given in terms of phi that 0, phi, pi by 3, f phi is 1. So 0. So when phi is 0, what is psi? When phi is 0, what is psi? 0, right? And when phi is pi by 3, what is psi? Are you sure? Minus 2 pi. So psi would be at phi equal to pi by 3. This will be pi times cos of pi by 3 minus 1. What is cos 60 degree? Cos 60 degree is half. So half minus 1, that is minus pi by 2. So f psi equal to 1 for minus pi by 2, psi 0. Is it all right? Is it all right? Somebody is waiting. Wait. Right? We carry on. Pi by 3, psi 2 pi by 3, f psi is 0. Okay. Now this we have already seen, this is minus pi by 2. What is this? What is this? That is pi of cos 2 pi by 3 minus 1. What is cos 2 pi by 3? Cos 2 pi by 3 is equal to minus half minus 3 pi by 2. Okay. So second expression is f psi equal to 0 for minus 3 pi by 2 we can write this as per the specifications. Is it okay? Is it okay? Can be okay, right? Finally, third specification is 2 pi by 3 phi 2 pi, if phi is 1 again. So phi 2 pi by 3, that is equal to minus 3 pi by 2, this we know. Here this will be pi cos pi minus 1, that is minus 2 pi. So the third expression is f psi equal to 1 for can we write this? Can we write this? So what are the three final expressions? The three final expressions are f psi equal to 1 0 1 okay. Is it okay to write this? Sorry, this will be shy. Sorry. Okay. Is it okay? Okay, we will continue in the next class, next session.